next introduction example when it comes to differential equation is that we have to look for the solution. Now, as for our introduction examples, we will only use the method of integration, the basic method of integration here. So, on our first example, we have the differential equation as derivative of y with respect to x is equal to 12x squared. Then all we have to do is just simplify this. So we can multiply the dx by 12x squared. So this is now expressed as dy equal to 12x squared. Then we can evaluate the integral of left side and right side of this equation. Then we have the integral of dy, which is y, and this is the integral of 12x squared dx, which is by power integral, which is equal to 4x cubed, and then upon integration is plus c. So this is a basic method how to find the solution for this differential equation. Another example is we have dy with respect to x here equal to x over 1 plus x squared. So similarly, we have to combine the variable x with the dx. So we will simplify by multiplying or cross multiply with the dx. So we have dy now is equal to x over 1 plus x squared and then dx. And then to find the solution, all we have to do is just evaluate the integral of each, the left side and right side of the equation. So we have the integral of dy for the left side. And for the right side, we have x dx over 1 plus x squared, which can be evaluated by means of, this is leading to loan method. So where the derivative of the denominator is 2x dx, which is given in the numerator, where we only have to add 2 to complete the du together with correctional factor of 1/2. So we have y for the left side. And on the right side, this is 1/2 ln of 1 plus x squared, and then upon integration plus c. Another example is, for number 3, we have derivative of y with respect to x equal to sine 2x. So again, as for the basic method, how to find the solution, we just combine the dx with the x variable and y with the dy variable, or dy with the y variable. So here we just multiply by the dx for the equation. So on the left side, we have dy, and then on the right side, we have sine 2x dx. So to find the solution, all we have to do is just get the integral of each side. So the integral of dy is y here, and then this is integrable directly. We have the integral of sine 2x dx is 1/2 cosine 2x, because we need to add 2 and 1/2 as a correctional factor. And for number 4, we have dy with respect to x and equal to x square root of x minus 6, and then combining the x variable with dx, so we have dy on the left side, and on the right side is x square root of x minus 6 dx. Then, all we have to do is just evaluate the integral. On the left side, this is by means of integration by algebraic substitution, because this is not integrable directly, then it contains a radical expression, so might as well as use the integration by algebraic substitution, wherein we can express or set that the given radical will be equal to a certain variable, let's say z. I use the z here, which is equal to the radical, and then we can look for the value of x by squaring both sides. Then the x now is z squared plus 6, and then looking for the dx. This is 2z dc, and then substituting on the given integral here, we have this time the integral of x can now be replaced by z squared plus 6, and then the radical expression square root of x minus 6 can be replaced by z, and the dx can now replaced by 2z dc. And then simplifying by multiplying the z times z square, multiply by z square, so this is z to the 4th, and then multiply by 6, so this is 6z square. And then we can express the constant as the numerical coefficient here, and then this is integrable now by power integral. Add 1 to the exponent, so this is z 5 over 5. Add to the exponent, so this is now z cubed over 3, and 6 divided by 3 is 2. Then the next part is we have to substitute again the value of z here. wherein the z is square root of x minus 6. So we just substitute. Therefore, the integral of the right side is now 2 and then multiplied by 1/5. So this is 2 over 5. And then square root of x minus 6 raised to the 5th plus 2 square root of x minus 6 raised to the cube plus c. And then on the left side is y. So this is now the solution of that integral.